taking this one. Okay, so question is determine. So one determine MR. MR, that means the matrix. Okay, and second is the relation R. Relation R, and the set is already defined. Set consists of 1, 2, 3. Okay, start with this, and one more question from the closer also I'm giving. Okay. Yeah. From the if suppose if point A is equal to 1, 2, 3, 4. Okay, R is defined by 1, 4. Then you can write 2. Then 2, 3. And this 3, 4. How many elements? 25. Okay. If A and R be a relation defined on A, so question so it's question. Okay. And I will discuss this one also. So start from this one. So you know how to find the bijection. Bijection means? Bijection means?
1, 1, 1.
1, 2,
1, 1.
1 on 2.
1, 1 on 2. That means injective plus, yeah, 1, 1. Injective plus adjective. 1, 1 plus on 2. 1, 1, that means how can you show that 1, 1 on 2? Because you write 1, 1. How to show that? Is equal to FB. This implies A is. Hello?
Sir, your screen is freeze, sir.
Yes, sir.
Just a minute. Just a minute. Maybe there's some tower problem there. Just. Now is it visible properly?
No, sir. Yes, sir. Now it is visible.
Yes, sir.
Okay. Okay. Now you see how to show that 1 1 1 1. That means if FA equals to FB, this is for the one dimension. And you see in the question number 3 of 1, you have a suppose if you are taking this XY, okay, is equal to, because it is a two dimension R cross R. So if you are taking this, so this should X is equal to U and Y is equal to V. You have to show this one. This is for the third case, and for first and second case you have to show that for 1 1. What is the onto? Onto means, you see, if it is the domain and it is the codomain, okay. So if y, this is the y and this is x, if y can be expressed in terms of x, and again if it is possible to express x in terms of y, suppose y, then it is 1 to 1. First is 1 1 1, and onto that means onto, if onto means there should not be any element in y which is not associated with x, okay. That means if inverse exists. So if it is possible to show that this is the elements of x and this is y, so we generally write in these forms. Now if it is possible to express x in terms of y, okay, if x in terms of y, then it is onto. So we have to show that two things, one this, and if y is given, then for all values that lies on the codomains, for that we must have this quantity. That means if it is possible to express x in terms of the y, then it is onto. So if these two possibilities occurs, then we say that it is 1 to 1. And solve it. Question number 1, and tell me what about this one. All the threes are of the different kinds.
First one, sir, first
Yes.
one is bijective. Second one is not bijective, sir.
Why not bijective?
Sir, onto is not possible.
Why?
Sir, because when we will put the value of x now, then it will come infinity, I guess, sir.
No, no. So you see, for the second
Sir, it is
one,
giving
okay.
two
For
value
the
at single point since it is exponential
ln
function.
x. So sorry. No, not two values. You see, sorry.
But it won't exist for the values lesser than or equal to
Yes,
0.
yes. This is the reason. This is the reason. So although it is the 1 to 1, no problem, but it is not onto. Whatever. Because if y equal to e to the power x, then x is equal to log y. Okay, and it is from r to r, r to r. That means y assumes the value r, and if the y assumes the value negative values or the 0, then it is not possible. No, you see. For this, y is equal to e to the power x. This implies x equal to ln y. And you see this x belongs to r and this x also belongs to r. Okay. Now, this belongs to r. That means it includes negative 0 as well as the positive also. But this function is defined for positive only. Okay. So, all the elements of, as per the definition, all the elements of these functions are that means we are getting either plus infinity or minus infinity. That means for all the values of y belongs to r, the function is not defined. Is the function, if the function is not defined, that means it is not onto. It is not onto, but 1 1. So it is the not bijective. Not bijective. It is bijective. Bijective, how you write it? Y is equal to, for first one, y is equal to 3x minus 1, therefore x is equal to 1 by 3 y plus 1. Now you see here, this belongs to R and this also belongs to R. So for this function is defined for all R, and for all R you get a unique solution in this X, that means domain. For all values of R, that means all values in the codomains, you will get a definite value in the domain. Okay, so it is the 1-to-1 correspondence. What about this third one? What about this third?
Sir, just
Sir, it is 1-1, I guess.
It is 1-1.
Yep. Yes, sir.
Obviously, you see here it is x plus y, x minus y. Okay, x plus y and x minus y. So let me write in. So you see here what? Suppose this
Sir, it
one.
will be bijective, sir.
Okay, so suppose this is equal to this. Okay, so now if this equal to this, and if it is possible to show that this, that means it is 1-1. So what you are writing, x y, so xy equals to how much? Fxy is equal to how much? X plus y. So you can write it like this, x plus y, and it is x minus y, and this is equal to u plus v and u minus v. So x plus y is equal to u plus v. Okay, and x minus y is equal to u minus v. Okay, now solve it. If you solve these two, so what you will get? So this and this cancelled out, you will get twice x equal to twice u, and this implies x is equal to u. And next, if you subtract this one, so minus this becomes plus, so you will get 2y, sorry, 2y. What? So if it is the truth, then y x is y is equal to v. Now you have to show that it is the onto, it is 1-1 onto. What happened to this? Okay. So we are getting what happened to this? Just a minute. So solve the problems. I will see what happened to this. Okay, so it is twice y is how much? Cancel out this one, cancel out minus plus. So twice v implies y is equal to v. Okay, we are getting this. Now we have to, so that it is a 1 1. Hello. Hello.
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Now suppose we have to another pair st in codomain. Okay, codomain. So then that means this is the xy point. Okay, you have a uv another, and we have a st also. Okay, now st is the in the codomain such that x plus y. So x plus y equals to s, and x minus y is equal to t. Now, if it is possible to express s and t in terms of x, because it's s belongs to r and this is also belongs to r. Okay. Now, if it is possible to express s and t in terms of xy, that means it is onto. So it is easily you can show that this becomes how much? X is equal to half s plus t, and y equals to how much? Just s minus t, and this is half. So what do you see here? S and T are the elements of the real number. We have a, you see here, we have a function f from r cross r to r cross r. Okay, so this is s, this is t, and this is x, this is y. So s, since this s and t, this also belongs to r. So their algebraic operations over here, s minus t or s plus t, also give a real number. So x and y are already priorly defined. These are the real numbers. That means it is a one-to-one function. So 3 is also a bijection. So what is the difference between these three? First and second are the singleton set. This one and this one, single valued in fact. But this is not a bijection, but it is a bijection. And this is the two variable function, which is also a bijection. Okay, come to the second one. How to solve it?
Sir, first we can find. We need to find the function. Sir, it is coming as fz is 3 by 1 plus z.
3 by 1 plus z. It's okay. How you solve it?
So just putting the value of A0, A1, A2 in the
Actually,
equation.
you see, when you are forming the generating function, so just recall the generating functions. This is for all. Generating function actually gives the what coefficients. Actually, generating function is the power series. Generating function is a power series, and this generating functions gives the, you see here, these are the sequence. So member of the sequence are the coefficients of the generating function, and generating function is the power series. Okay, like you see here, suppose we have so that means if we have like z plus az plus a1, a2z square plus a3 z cube plus so on. So these a1, a2, a3, these are the member of the sequence. So in our cases, what is the sequence? It is suppose 3 minus 3, 3 like this. So if it is, then construct the power series, it is 1 plus z. So this equals how much? 1 minus z. Why I'm taking the plus over here? Because we have alternately plus minus plus minus. If all are plus, then we'll take a minus. So it is z square minus z cube plus z4 and so on. Okay. And if you multiply this by 3, so what you will get? It is 3 first entry minus
1 plus z. Sir, 1 plus z. 3 by 1 plus z.
Sorry, yeah, 1 plus z. So minus 3z plus 3z square minus 3z and so on. Okay. And this can be written as a 3 plus minus 3z. Okay. Again 3z square plus minus 3 z cube and so on. So this is the actually generating functions, or in the abbreviated form you can write it. It is a 1, 2, 3. So it is to the power n, and n varies from 0 to infinity. So this is your required generating function. Okay. Is it
Sir,
clear?
I thought we have to represent in the form of an plus minus an minus 1 or an plus 1, something like that.
An
Plus minus an minus 1 or an plus 1.
that is the recursive formula.
Okay, sir.
That is the recursive. This is the generating function. Okay. So same sequence can either be expressed in terms of the recursive formula or the generating function. Is it? Sometimes recursion is useful, sometimes generating function is useful. But here particularly I specify this generating function. Okay. And come to this the second one. These are the NCR. Okay, CNR. Meaning of this NCR, then NCR. Binomial coefficients. So how you write it? First entry this. So directly I'm writing here 80. 80, that means it is in the form of total 8 entries are there. So 8 entries are there. So you can write it 1 plus z to the power 8. Okay. So sorry, 9 entries. I'm saying how many it is? 0, 1, 2 up to 8. You can see here. You see here we are starting from the 0, 1 up to 8, and rest are 0. That means we have a 9 elements, 9 components of the 9 entries. So we need to raise the power to 8 so that we can get 2, because if you are writing the 1, then we will get the 2 terms. If you take 2, then we will get the 3. So if you put 8 here, we will get the 9. So what are the entries? C 80, z to the power 0, okay, plus This is exactly the binomial coefficient. That's why I'm writing in this form. C81, Z1, C82, Z2, and plus so on up to C88 and Z to the power 8. Leave it, okay? So how to construct the generating function and plus 0. These are the 0 z to the power 9 plus 0 z to the power 10 and so on. So how you write down this one? You can write it in the form of the C8R or whatever may be n, write in x to the power n, and n from 0 to infinity. Greater than 8. Okay, so rest term becomes obviously 0. Okay.
Yes, sir.
Question number 3. Question number 3. Everybody solve it.
Sir, have you written mod over there, sir? In R is equal to xy.
No, not
Achha,
mod.
X.
Element is xy. That means ordered paired. Okay.
No. After that, after the x minus
It is
y is
not a matter. Okay. If you have any problems, then I just make it correct. Write in this way. Okay. It is set builder form. R consists of the ordered pair xy such that x and y are related by this. Actually, this is your R. X minus y is divisible by 3. This is your relation. Okay. And R is the ordered pair xy. So how you define this one? It is the x such that x is less than equal to 7 and x belongs to natural number. That means it starts from 1, 2, 3, 4, 5, 6, 7. So this is the set A and R is defined in such a way. We have to find it. How you will find this one? Is it a equivalence relation?
No, sir.
First of all, check it. 1 to 7 and then divisible by 3. Is it reflexive?
No, sir.
1 minus 1 is equal to how much? 1 minus 1 is how much?
0, sir.
Is 0 divisible by 3?
Yes, sir.
Is 0,
Yes.
then it is reflexive.
Yes, sir.
So A is how much? This is question number 3. A is 1, 2, 3, 5, 6, 7 and R is
Sir, it is
x
reflexive.
such that x minus y divides 3. Okay. So you say first one is you say take A belongs to A. Okay. Then and A assumes the value 1 to 7. Then A minus A is equal to 0. Okay. Which is divisible by 3. So therefore, what do you see? X is R related to Y. Okay. For all, sorry, it is not X is R related to X. For all X belongs to A. So therefore, R is reflexive. Then after that, symmetry. How can you check it? How can you check this one? XY belongs to A. Okay, and
Sir, it is not symmetric.
now you see here xy belongs to A. Therefore, x minus y is equal to 3, suppose s. It is divisible by this. Okay, and s is an integer. An integer. If x minus sorry, it is divided by 3. Okay, I'm not. I should not write in this way. X that means x minus y is divisible by 3. Okay, it's okay. X minus y is divisible by 3. Now this implies what? Y minus x is equal to 3 times minus s. Okay, so this implies y minus sorry. So implies y minus x is divisible by 3. So x is r related to y. This implies y is also r related to x. For it is not xy, all xy a. So it is symmetric. Symmetry. Transitive. Is it transitive? You have to say something. Is it transitive?
Checking.
X, y, z belongs to A. Okay, and then x are related to y. This implies x minus y is equal to suppose 3s, and y are related to z. This implies y minus z is equal to st. Okay, now x is r related to z. This implies what? Or
X y plus y minus z.
just a minute. To y and y is r related to z implies x minus y is equal to thrice s and y minus z is equal to thrice t.
It is transitive.
Implies now sum of these two. Sum of these two, how much? X minus y plus y minus z. This is equal to 3 times s plus t. Implies x minus z. 3 times s plus t. These are st are the integers. Okay. So what you see here implies x is r related to t. So what do you see? If x is r related to y and y is r related to x, so it is transitive. So it is equivalent. Just a minute. Hello. আমি এসেছি, আমার ওই সিস্টেমে একটু প্রবলেম আসছিল, এই জন্য আমি ক্লাস নিচ্ছি, বাড়িতে নিচ্ছি। হ্যাঁ, ছুটি নেবে না? ফার্স্ট হাফ নেবে না? ছুটি ঠিক আছে, আমি আসছি ক্লাস নিয়ে। 12টা অবধি আছে ক্লাস। 10 মিনিটে আসছি। ঠিক। So now R is transitive, therefore R is an equivalent relation. Equivalence relations, I think. Equivalence relation. R is an equivalence relation. R is an equivalence relations. Okay. Now one thing you read, that is the equivalence class. What is the equivalence class? And you say question number 4, very important. How many reflexive relations? This is very important. Okay. So I'm not going to explain this much. Everybody prepare this. And this is very important questions for objective type. How many reflexive relations and symmetric relations are there on a set of n elements? Okay. And is there any set A in which every relation in A is symmetric? Is there any set? Can anybody tell me what is there any set? Hello?
Yes, sir.
Is there any set in which every relation is symmetric?
Sir,
We are solving.
number.
No, sir. No, sir. Sir, are we taking the same set once more?
No, question is there exist any relations where you can see that for all the relations are symmetric? Any relations? Do you know? Any relations? Singleton set? If
Yes,
we have
sir.
only one element, then these are the simple tricky questions. Null set? Because what is the relations? Relation is a ultimately it is from R to R. That means a subset of Cartesian product. Okay, so Cartesian product. Ultimately, it is a set. Okay, so relation is the subset of the Cartesian product. So obviously, null set is also a relation. We can define that one. So the null set, is there exist any set A? Yes, there exists singleton set and that null set, which is always symmetric. Okay. Question number 5. Question number 5. Tell me, what are the values?
Sir, 1, 1. Sir, in first row.
You say it is reflexive.
Yes, sir. All the diagonal elements will be 1 then.
It's a sorry. It is reflexive. That means 1 is related to, you see, 1, 2, 3, and here also we have a 1, 2, 3. So 1 is related to 1, and similarly for the rest 2. So it is 2 is related to 2 and 3. So if diagonal entries have if the diagonal entries are 1, then it is symmetric. Sorry, reflexives. Now 1 is related to 2. So 1 is related to 2, and again 2 is related to 1. This. And what do you see? 1 is related to 3. Okay, and 3 is related to 2. Nothing else. That means it is not symmetric.
Yes, sir.
What is not symmetric? So what is the relation? Relation is 1, 1, R. R equals to how much? It is a 1, 1, 1 2 1 3 and then 2 1 and then 2 2 and then 3 1 3 2 and then 3 3. This. So these are the short type questions. 1 marks percent becomes. This is the lengthy. So do you remember this Warsaw's algorithm?
Yes, sir.
Yes, sir.
Can you solve right now? 5 minutes remain only. You have to find the transverse closure using the Warsaw's algorithm. Without using Warsaw's algorithm, also you can find the transverse closure. Okay, but it is easy to find Warsaw's algorithm. Take time, try to solve. Using the binary compositions, we can also, or the compositions of the matrix. Okay. So what is the procedure? What is the procedure? First step is to find the relation matrix. Yeah, W naught.
Then we will take. Yes, sir.
Probably I have given you the thorough notes of this also. Warsaw's algorithm,
Yes,
stepwise.
Yes.
Yes.
Okay,
Yes,
you
sir,
see
step.
that steps. Okay.
Yes, sir.
Okay, you do the.
Then we will construct W1 by considering first row and first column and
Okay.
then elements.
Simply tell me the W1. W naught, that means the simply the matrix, relation matrix. What is W1? So W naught is how much? 1 1 1 4. There it is 1 1 1 4 2 2 2 3 3 4. So it is like this 1 1 2 3 4 and 1 2 3 4. So 1 1 and then 1 4 and then 2 2 2 3 3 1 3 4. Total 5 entries are there. 0 0. Okay, now tell me W1. W1 will be how much?
Sir, can you please scroll a bit?
Now, first of all, you solve this one. Tell me the W1 first.
Sir, it will be same.
It will be?
Same, sir.
Sir, same होगा.
Okay, same. Then W2?
Same, sir.
W3?
So it is again same.
W3?
So it is same again.
2 4 will become 1, sir.
No, row wise tell me. 1, next.
001,
001, next.
0111,
0, 111, next.
0001,
1, next.
0000.
Yeah, it's okay. So this is the transverse closure, transitive closure. And next W4 also you will get the same. Okay. Actually W3 again you have to construct the W4. In the W4 you will get the same. Okay. It has the 4 elements, that means you have to move up to W4, and in W4 also you will get the same value. So this is the final stage. Final stage should be this one, but the transitive closure is this. So what is the transitive closure? It is a 1 1, then 1 4, then 2 2, 2 3, 2 4, and then 3 4. Some more it is full including. So next class we will solve more problems related to this. Okay, and if possible, then in this before the review vacations, okay, prepare for the third quiz, and in third quiz we have 1 or 2 topics remains, that is the big M and the omega n function.
Yes.
So we'll complete that one. Yes.
So when we are taking W2, we are taking second row and second column.
Second row, second column. Yes.
Sir,
When you are taking, yeah.
Then it is coming 2 2 and 2 3 2 will be assigned, and 3 2 we have not assigned.
No, you simply check that one. Okay, you simply check that one. I am not going to solve here. Otherwise, I will see this one. Okay. Actually, maximum students are getting the same, and that's why I'm writing here same. Still, I am not taking this one. Yes.
So I got also the same 2 2 and then 2 3 only.
In W2.
Yes, sir. After W3 again, so same answer.
Sir.
After W3, you will get the same.
Yes, sir. There is no matrix.
Sir, but in W2 only there is some mistake, sir.
In
Yes,
W3, in W3. W2.
In W2.
Okay, everybody first solve it. I will also solve this one, and then in the next class we will discuss this one. Okay. Because time is almost. Okay, let me take the attendance. Okay.
Thank you, sir.